Okay, here's a graph depicting the situation. This is the graph of y squared equals 4 over x, parabola opening to the right. And here's the boundary x equals 4, and the boundary y equals 0. And we're supposed to revolve around the y-axis, or the line x equals 0. When you use the washer method, you want your typical rectangle to be perpendicular to the axis of revolution. So that's what this little line here represents, is a typical washer. Okay, and we want to use the formula, the definite integral of pi times the outer radius squared minus the inner radius squared. So, for example, for this typical washer, the outer radius is the distance from the axis of revolution to the furthest most point, which is always 4, no matter where this washer is. That distance is 4. But the inner radius is this distance right here. And that's x distance. So we need to solve for x in terms of y, which is what I did here. X equals y squared over 4. And as an example, when y is 2, x is 1. And so the inner radius is represented by y squared over 4. For every y value between 0 and 4, that distance right there, I take the y number, square it, divide by 4, and I've got that little x distance right there, which is the inner radius. So there's an expression for outer radius squared minus inner radius squared. So if I simplify this a little bit, I've got 16 minus y to the 4th over 16 dy. And the antiderivative of this is 16y minus, well, I've got this 1/16 out front, raise the exponent to 1, multiply by the reciprocal of the new exponent. So that's where I get this 1 over 80. And I want to evaluate this from 0 to 4 and multiply the whole thing by pi. Okay, and so if you put 0 in for y, you're going to get 0. So it's pi times, well, 4 in for y gives me 64 minus 1/80th of 4 to the 5th. Well, I'm just going to leave it 4 to the 5th and let you simplify it from there. I can see that, well, I'll take it one more step. I've got 64. I can see that 16 divides into 80 5 times, which leaves me 4 cubed in the numerator. If you get a common denominator between those two terms and subtract them, that's where we get this 256 over 5 times this pi sitting out front. And here's the definite integral evaluated on Gizmos. Looks like they're the same value. So there's your answer. Exact 256 pi over 5. Okay, hope that helped.